This tutorial is about calculation of cumulative incidence or incidence proportion in R software. If you haven't already downloaded RStudio and R software, you can download from the link in description. Let's start the calculation. The first step is to load the package. You will require epir package in our library here. The library function tells R to load the package so that you can use the function in that specific package. It is like a toolbox. R itself comes with many tools, but specialized analysis such as epidemiological data analysis often require additional toolboxes called packages. So epir is designed for epidemiological data analysis. It contains functions that help calculate measures, for example, incidence proportion or cumulative incidence, incidence rate, prevalence, risk ratio or relative risk, odds ratio, sample size calculation, and many others. So instead of writing complex formulas yourself, you can use a single function to perform these calculations in epir. Why do we need to load it? Actually, the functions in a package are not automatically available in R. You will have to load them by this command, library epir. For example, if you will try to use the function epi.conf without first loading epir, the R will return an error message. After loading the package, all of its functions become available for use during your R session. If epir is not installed on your computer, you can install by using install.packages bracket and by writing the name here, epir. Once it's installed, then every time you start a new R session, you can load it by just running this function library epir. Now come to our calculation with this scenario. This is a single sample example. Suppose we followed 300 disease-free individuals for 1 year to determine the occurrence of influenza. Out of these 300 susceptible persons, 50 developed influenza during the study period. So we want to calculate incidence proportion or risk or cumulative incidence with confidence intervals. This number sign here tells R that this is text, and R will ignore these lines. So next step is to define data or numerator and denominator. Here we create two variables. This pose representing the number of new cases, and this pop variable representing the total population at risk at the beginning of the study. This line prepares the data in the format required by the epi.conf function. So let's break it down. Here this dot means the name of this matrix. So I chose dot. You can choose any name, X, Y, Z, or whatever you want. Here cbind means column bind. It combines the two variables into one table. If I run this code, the output will be like this. So here we have two columns. One is for positive cases, one is for population. R has combined these variables in a table. As matrix converts the combined data into a matrix, here you can see that R has converted our data into a matrix with one row and two columns. Next, we will calculate the incidence proportion with 95% confidence interval. This line will perform the function. In this code, this epi.conf function calculate different estimates, for example, prevalence, incidence rate, cumulative incidence, together with the confidence intervals. In this line, this C type means calculation type. I'm calculating cumulative incidence or incidence risk. You can calculate any other measure, for example, prevalence or incidence rate, mortality rate, by adding the specific name here. You can find all details here in epir. If you open it, here we have this epicom function. If you open it, you can find all the information here, and there are also examples available if you want to calculate some other measures. So there are a couple of examples in this description. This method in line tells R to calculate the confidence interval according to exact method. There are several methods available, but exact uses the Klopper-Pearson exact binomial method. This method is preferred when sample size is small, number of cases is low, or a precise confidence interval is desired. N specifies the population at risk. Since all 300 people were at risk, so N is equal to 300. The design specify the design effect. A value of 1 means that the data comes from a simple random sample with no adjustment needed for complex survey designs. If you have data from complex survey, you would have to add specific design effect value here. But for most introductory epidemiological analysis, we assume design effect is equal to 1. This requires a 95% confidence interval. This means that if the same study were repeated many times, approximately 95% of the calculated confidence interval would contain the true population cumulative incidence. The digit 4 rounds the result to 4 decimal places, and this will multiply the output with 100 to convert the result from a proportion to a percentage. Now I will run the code. So our estimate is 16.67% with confidence interval 12.63 to 21.38. The output includes estimate and confidence interval. You can interpret the result as the 1 year incidence proportion of influenza was 16.67% with 95% confidence interval ranging from 12.63 to 21.38%. This indicates that about 17% of the initially disease-free individuals developed influenza during the 1 year follow-up period, and we are 95% confident that the true population incidence proportion lies within the reported confidence interval. I hope you can calculate incidence proportion or cumulative incidence by yourself now. Thank you for watching, and bye.